Okay, we're ready for the instrumental variable proof. I hope you are excited for this. So I'm going to go again and refresh our assumptions one last time. Suppose we have an instrumental variable that we are interested in. It has a causal effect on our treatment, which has a causal effect on our outcome. Now we can't measure the causal effect from our treatment on our outcome directly because there is some confounder, u, that we know about and necessarily can't control for. We can't measure for it in this example. So we said one thing we can do is we can go ahead and we can figure out what the intention to treat effect is if Z is a treatment. So if we treat Z, so for example, if Z is giving someone medication and A is taking the medication. However, what if we're interested in the actual effect of taking the medication? This would seem really useful, especially for doctors. So what could we do? Well, I said we can use instrumental variable analysis to do so, but we need 4 assumptions. So assumption number 1 was that Z, I can go ahead and actually write this out here too. So assumption number 1 is that Z has an association with A. Assumption number 2 is that there is no direct causal link between Z and Y. Assumption number 3 is that Z and Y are exchangeable. There's no common causes and you haven't conditioned on common effects. And the final condition is that there are no defiers in the population. All these conditions are going to be needed, and I'm going to be talking about why they're needed during this proof. If you are unfamiliar or less keen on any of these assumptions, please go back to the following or the previous 2 videos in the playlist to check them out once again. So let's get to it. So I'm going to go ahead and say, let's say we are interested in Z sub Y or Y sub Z minus not Z. So the causal effect of Z on Y. We can go ahead and measure this. Why? Well, based on our assumption number 2, Y and Z are exchangeable. Because they're exchangeable, their association equals their causation. We can measure the association between Z and Y pretty easily. So this is a measurable quantity. So this is good. We like this type of a quantity. So we know this quantity is composed of a couple of things. So we know this quantity is composed of 1, the causal effect from the always takers. We know it is composed of the causal effect from the never takers. Never take. We know it is composed of the causal effect from the compliers. The compliers. And we know it is composed of the causal effect of the defiers. So it is a weighted average of the always takers, the never takers, the compliers, and the defiers. But what do we know about each of these populations? So 1, we know that the always takers are always going to take A, regardless. And we know that Z's only effect on Y comes through A. This was the second assumption, exchangeability was the third assumption. This is the second assumption. Z's only effect on Y is through A. So if they always take A, Z will have no causal effect on Y in the always takers. So this equals 0. For the never takers, it's the same thing. They'll never take A. So Z can have no causal effect. This also equals 0. The final thing we know is that by assumption 4, there are no defiers. So we can cancel that out as well. Okay, this becomes pretty simple. So we go ahead and we take this quantity that we can calculate, which is the causal effect of Z on Y. And this will equal, in this case, this is the causal effect of Z on Y of the compliers, simply times the proportion, P, the proportion of compliers in the population. I'm going to go ahead and I'm going to move the proportion of compliers in the population to the left-hand side. So I'll go ahead and I'll get Y sub Z, the causal effect of Z on Y, divided by the proportion of compliers equals something on the right-hand side. Now, I want to mention 2 things here. So once again, we can figure this out. We can figure out what the causation of Z on Y is because they are exchangeable by the third assumption that we made. And because they're exchangeable, we can take their association to be equal to their causation. Nice. The second thing that we can do down here, the probability of compliers, we know that by the first assumption, this should not be 0. So what if no one complied? So what if there was no association between Z and A? So what if I gave people their medication and then they just kind of like randomly took it or not? So they're either always takers or never takers. Well, that would be a problem. No one would be a complier in our example. However, we know from the first assumption, because Z and A are associated, that there is some proportion of the population that is compliers. So from our first assumption, we know this is true, and we can calculate the association between A and Y. Technically, I do want you to sort of like see this because I think this is pretty cool. Technically, this equals and this is for a little bit more mathy probabilistic people out there, this equals the covariance between Y and Z divided by the covariance between Z and A. I just want you to, I just think it's very, very pretty how this kind of thing worked out to such a simple little formula. Okay, and so we know this equals Y comply, Z minus not Z. So the average causal effect from Z on Y in the compliers. Now, what do we know about the compliers? Well, we know that when the compliers get the assignment of Z, they will automatically take A. So if they're given pills, they will take the pills, they comply. And if they're not given Z, if they're not given the pills, they'll go ahead and stay away from the pills. They'll also comply. So what's interesting here is we can actually sub this out. We can go ahead and instead of saying the causal effect of Z on Y in the compliers, we can go ahead and say, hey, we don't need to say it's the compliers anymore. We can go ahead and say this is the causal effect of A on Y. Okay, pretty cool, right? And this is because if you give someone Z, they'll go ahead and they'll comply. So Z is essentially A in this example. Okay, so I hope you kind of see what we've done. We've taken something that we can calculate right here. Let me go ahead and sort of put a little star right here. We can calculate this pretty easily, the covariance of Z and Y and the covariance of Z and A. And this will actually equal the average causal effect of A, our treatment, whatever that may be, on the outcome. Okay, this is the full instrumental variables proof. There are a couple caveats here. Instrumental variables tend to make very, very wide confidence intervals, especially if the instrument is not very associated with the treatment that you are interested in. We can talk about that a little bit later on. And the second thing, there's a lot of assumptions here. The first 3 assumptions are basically the assumptions that we've made. Again, we have to make these assumptions. These are very similar assumptions that we've made on A that we need to, again, make on Z. So they're very untestable. Assumption number 2 and number 3 are untestable. So we can test if Z is correlated with A, that's totally fine. But we can't necessarily test conclusively whether Z is exchangeable with Y or whether Z has no direct causal effect on Y. So that's too bad. The final assumption as well, the no defiers assumption, this can be obvious in some cases, but also it can be painfully obvious that there are defiers in other cases. One final thing that we have sort of glossed over here. So this is the causal effect. So once again, you kind of might be curious, why did I leave this compliers out? So I technically sort of kind of added this in of comply. So I technically should have added this in. This is the causal effect of on compliers, the subset of the population of A on Y. Now, why is this important? So not everyone in the population are compliers. Perhaps compliers are a different type of person. So again, compliers in one so for example, if you do 2 instrumental variable analyses with 2 different instrumental variables, you might get different effects because the compliers in both of these examples might be different types of people. They might comply for different reasons. And so it's very hard to sometimes sort of extrapolate this out to the full population. So people might hear this sort of instrumental variables analysis result and they might be like, well, the compliers are a very small percent of the population. And so why do we actually want to adopt this policy if only compliers will benefit? There's a lot of concerns here. Perhaps at a later point, I'll go ahead and I'll make a video on sort of the concerns from instrumental variable analysis. But I think this has gone long enough. So I hope you've liked this, and I'm going to go ahead and give you a little bit more intuition on instrumental variables in the next videos.